Hello, Bio 30 class. This is Mr. MacKay again. Today I'm going to do the solutions for the dihybrid question sheet that you got on Tuesday. We'll start right off again. I'll try to go fast and feel free to stop the video whenever you need to. So question number 1. Green pea pod is dominant to yellow pea pod. So always start with your legend. Big G for green, little g for yellow. And tall plants are dominant to short. Big T for tall, little t for the recessive short. So we now have 4 different alleles possible. Across a homozygous green, so homozygous green means both letters are the same, and a heterozygous tall. That's one parent. With a yellow, if it's yellow, it must be homozygous recessive, and heterozygous tall again. Big T, little t. So now we have the 2 parents. Step 3. Step 1 was to create your legend. Step 2 was to show the parental cross. Step 3 now is to make the gametes. So starting with the first parent. The gametes possible, we have a big G and a big T, or we have a big G and a little t. Those are your only 2 possible gametes. You could write those down again to get all 4 if you want, but it doesn't matter. You're just doing more work than you need to do. So there's only 2 different possible gametes for the first parent. The second parent, we have a little g and a big T, and we have a little g and a little t. Those are the only possible gametes for that. So now I do my Punnett square. And now I have to fertilize it. Very important when you fertilize it to put the same alleles back together again. So the first allele, let me get a different color. We've got a big G and a little g. And then the second trait is going to be big T, big T. Next, it doesn't matter which box you do in what order, so we've got a big G, little g, and a big T, little t. Over here, big G, little big T, little t. Big G, little t, oops, get that out of the way, little t, little t. A couple of conventions you have to make sure you always follow. When you have a heterozygous condition, you always write the capital letter first. I would recommend, it doesn't matter which trait goes in front, the G's or the T's. I've obviously put my G's in the front. So always keep that same convention with whatever you started. So I'll always go G, the 2 G letters, and then the 2 T letters. Always, always, always. Now, if somebody went T's and then G's, that doesn't make it wrong. They would always stick with that solution as well. So last thing you need is your phenotypic ratio. Rarely would they ask for genotypic when you do a dihybrid question. So phenotypic ratio, starting with the top left box. Big G, little g, big, means that this thing is going to be green and tall. What else do we have that's green and tall? This one is also green and tall, and this one is also green and tall. That means phenotypic ratio is 3/4 green and tall. 1/4 is going to be green and short. Next page. Same legend. I'll write that out real fast. Green, yellow. Oops, yellow. Tall, short. Across heterozygous green. Heterozygous tall. With the heterozygous green, short. So the first parent, gametes you can get. Big G, big T. Big G, little t. Little g, big T, little. 4 possible gametes. That's the most you would ever get, by the way. Other parent, we can have a big G and a little t, and a little g and a little t. So only 2 there. So we got a 4 times 2 box, or an 8 box Punnett square. 4 times 2 equals 8. Now we fertilize. Big. I'll go pretty fast here. And next we have to do, of course, is the phenotypic ratio. This one's a little bit more complicated. So I'll go over here. Phenotypic ratio. The way I would do it when your boxes get a little bit bigger is just take it 1 box at a time. So I'll look at the first one. This individual is going to be green and tall. And let's see how many green and talls we have. So there is one green and tall. There's two greens and talls. I'm looking for at least one big of each letter. There's another one big of each letter. So it looks like I've got 3/8 green and tall. Now I'll pick another category. We've got this one here, green and short. So I've got a green and short there, a green and short there, and a green and short there. So that's 3/8 green and short. Now I'll do this one. That would be yellow and tall. Yellow and tall. And that's the only one that's yellow and tall. So that's 1/8. And lastly, down here, we've got yellow and short. So 1/8 yellow short. Done. Last one using the same legend. We had G, G, T, T. Short. Tall. Yellow. Green. Homozygous green and short crossed with a yellow homozygous tall. First parent, that's the only possible allele. Second parent, that's the only possible allele. So this is going to be an easy one. Big G, little t, G, big T, little t. So the phenotypic ratio here, 1/1 is going to be green and tall. Moving on to some different type of questions here. Free earlobes are dominant to attached earlobes. So big F for free because they're the dominant ones, little f for attached. Widow's peak is dominant to straight hair. Word of warning, W's are not great letters to pick because they look the same, so really make sure it's obvious in your work which is a capital letter and which is a lowercase letter. What is the genotype of the offspring of a man who is homozygous recessive for earlobes, little f, and homozygous dominant for hairline, big W, big W. Mates with a woman who's homozygous dominant for earlobes, big F, homozygous recessive for hairline, little w, little w. So the first parent, only possible gametes we can get here, little f, big W. Only possible gametes there is big F, little w, big, little, big, little. Notice that I put the F's back together and the W's back together. The genotype, all they asked in this question was what's the genotype of the offspring, is big F, big W, little w. That's all you need for that one. Trees. Green leaves. Whoops, that got messy fast, sorry. Green leaves are dominant to white. Don't make the mistake. Make sure that this stays as the same letter but lowercase. Smooth leaves, I don't like S's, so I'm going to go with an L for smooth and a lowercase l for rough. What are the results of a tree homozygous for both green and smooth? So that would be big and big, homozygous for green, homozygous for smooth. Is crossed with a white rough. White must be little g, little b, rough must be little l, little l. So possible gametes from the first parent, big G, little l. The other parent, little g, little l. Cross them, big G, little g, l, big L, little l. So results, all, or 1/1 or 100%, must be green and smooth. That's your phenotypic ratio. Next question. Tomatoes, red fruit dominates yellow fruit. So red, lowercase r for yellow. Tall dominates short. Show the cross between yellow and short. Yellow and short. Remember, each trait gets 2 alleles. Cross with heterozygous red, heterozygous tall. So from the first parent, you only have one possible gamete. For the second parent, big R, big T, big R, little t. little r, big T, little, little. So we got a 4 times 1 Punnett square here. Get a different color. So we got a big, little, big, little, big, little, 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 big, little, 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 little. Phenotypic ratio. We've got 1/4. The first one is red and tall. The second one is red and short. The third one is yellow, tall, and the last one is yellow, short. That was the last question. Sorry. That's it. Dihybrid crosses. Please make sure you're trying these out on your own on a piece of loose leaf. And again, like always, if you have any questions about them, feel free to email me and I'll do my best to answer them. Thank you very much. Have a good day.